Hi everyone. This is our look at limiting reactant stoichiometry. Limiting reactant stoichiometry is a kind of question that really does stand out because it's one where we have enough information to calculate moles for both of the reactants. Other questions, we can only find moles one time. So a defining feature of limiting reactant style problems is there's enough information in the question so we can calculate the moles by doing mass over molar mass or by doing concentration times volume for both of the reactants. We can find moles twice. What we're going to do after that is compare the two moles while referring to the balanced chemical equation. It's not just a straight up comparison, which one's more, which one's less. It's looking at those two numbers and also thinking about the balanced equation itself in order to decide which of the two reactants is going to run out first. The one that runs out first we call the limiting reactant. Why do we call it that? Because once it runs out, the reaction stops. When there's no more reactants, the reaction ceases and we stop making products. So the limiting reactant runs out and it limits the amount of product that we get. The other reactant, where we have extra, we have a fancier word for that, we say that it is the excess reactant. Because the limiting reactant runs out and it limits the reaction itself, it limits how much product we get, any stoichiometry that we're going to do, we're going to use the limiting reactant to do that stoichiometry. Our 4 steps now have been modified ever so slightly. No change at all to the first step. We're always going to balance the equation. We're going to interpret the question, get some labels in there like we have been doing all along. Step 2 is find moles. Only now we're going to be able to do that twice. This is always the second step. If there's only enough information to find moles once, that's still our second step, but now there's enough information to find moles twice for each of the reactants. Now I have this extra part of step 2. It's decide on the limiting reactant. And how are we going to decide? We're going to compare the 2 mole answers in reference to the balanced equation to determine which one runs out, which reactant is the limiting reactant. Once we make that decision, we're going to use the limiting reactant to do the stoichiometry. So after we decide on the limiting reactant, we're only going to use the moles of the limiting reactant and multiply by R over G and do the appropriate operation as our solving step. How does this look in practice? Let's just say, here's a balanced equation. 2 moles of A react with B to produce C. There's my balanced equation. Let's say that I did some calculations, mass over molar mass, or C times V, and I ended up finding that I had 6 moles of A and 4 moles of B. Which one's going to run out first? It's not just look at your answers and pick the smaller one. It's a little bit more involved than that. It's not just this is 6 and this is 4. 4 is smaller than 6, so it's the limiting one? No, it's more than that. We have to look at the 2 moles and refer to the balanced equation at the same time. So this says 2 A's react with B. So if I used 2 A's react with B. And I do that again. 2 A's react with B. And another time, 2 A's react with B. Oh, at this point, all of the A's ran out, but there's still B left behind. Even though this was a larger number originally, 6 compared to 4, because of the way that the equation is set up, A is actually going to run out first. So in this particular example, chemical A would be the limiting reactant because it runs out first. It is completely consumed by the reaction. Any question that I needed to answer about chemical C, I would need to use the limiting reactant, use A as my starting point for the stoichiometry. Limiting reactant questions, they don't really include any new math in our 4 steps. However, they've just expanded what's going on. A little bit extra work interpreting the question. We're going to have enough information to find moles twice. Most of the time we're going to be doing mass over molar mass twice. Sometimes we might be doing C times V. Other times we might even have the mole straight up told to us. We need to do some work. We need to compare the 2 moles while referring to the balanced equation in order to decide which reactant is completely consumed, which one runs out, which one is the limiting reactant. And then to answer any question that includes the stoichiometry, we're going to use the limiting reactant. The limiting reactant limits the amount of product. So any question we might have to answer about the product has the limiting reactant as the starting point. We need to see some examples. This is our introduction. I hope it helps.